Welcome back to Let's Go Design, your SOLIDWORKS interactive web series. This is episode 3 of the Hot Rod Baby Buggy. Last time out, we created our tracks. Now before we design the baby cockpit, we need to focus on propulsion. As a way to save time and money, I decided to reverse engineer some key components from a used golf cart. After ripping this thing apart, I'm hoping to reuse the axle, the differential, and the motor. My friend Tim is going to come by later with the latest 3D scanner technology so I don't have to model everything from scratch inside SOLIDWORKS. One of the best parts about the SOLIDWORKS community is our value-added reseller channel. My buddy Tim works at a local reseller here and I invited him by to help me out with this project. Hey Tim.
How's it going?
I'm good. Thanks for coming in. Here's the axle I was telling you about. I'd prefer if you could scan this thing accurately so I can model other pieces and not waste a week just modeling this stuff.
Not a problem.
So how accurate is the scan going to be?
How's 20 microns sound?
That sounds pretty good to me.
Gonna sweep the laser across.
Don't look at the laser.
And camera's gonna record it. It's gonna do about 500,000 to 1.2 million points per pass.
How many passes does it make for that one location?
I actually have it doing 6 passes right now.
All right.
So basically we'll shoot that area, we have to move, shoot the next area, have some overlap, line them up.
Wow, there are all the points, huh? Look
Yep.
at that. Now I need surfaces.
Right, so I need to bring this into my scanning software, polygonize those points into a mesh, give you a nice model for industry standard of SOLIDWORKS.
Nice. Tim, that looks awesome. That's exactly what I need. You know, I've got some other parts that I need to scan as well. I know you have to get back to work. Would you mind leaving this thing with me?
Not a problem, just be careful.
All right, I will, promise.
See you later.
See ya. Thanks to the Laser Genie / reseller, we now have our axle and motor. So I appreciate Tim for coming by. I can take this component now, mate it to the tracks, and then jump into simulation and rapid prototyping. In order to conserve the width of this overall design so that we fit on a sidewalk properly, the key is to build a hub off of this face plate. So what I have to do is create a rim that stands off 4 inches. And then what I'll do is I'll bolt our outer sprocket to that. And then I need to make an 8-inch spacer that goes inward towards the motor. And then I can add inside sprocket to that. All of it can be held together with 1/4-20 cap screws, and then I can use the existing lug nuts from the golf cart. That looks good. As long as that's concentric around the axle, it'll rotate perfect. And all I have to do is add the tank treads. At 3.5 feet wide, this will definitely fit on a US sidewalk. We might have to make a miniature version for you guys overseas. All right, that looks really good. What I'll do is I'll post these files to the download section of the Let's Go Design site, and you guys can play around with the tank tracks. Now, you guys remember my friend Stephen Endersby. Not only is he our SOLIDWORKS simulation guru, but he's also a real dad.
That's right, Jeremy. I've been hearing rumours about this infamous baby buggy project you've been doing, and I've come down here to be the voice of reason.
Tank treads starting to worry you a little bit?
Tank treads, children, it's never good. It's never good.
All right, Stephen, before I start rapid prototyping the drive sprocket assembly here, I just want to do a sanity check on the design.
You're pushing this over an existing drum. This side here has no support. What would concern me is that you're going to put an awful lot of bending load through this spacer. So will these bolts pull out? Or alternatively, if it's too flexible, will it actually drop down and start to bind on top of this drum? Both not good.
I mean, it actually is set up just like a wheel bolts to a car axle, so...
Yeah, but that's the thing. Do you think, or do you know? I think it's time we should actually use SOLIDWORKS simulation just to find out.
Let's do it. All right, Stephen, so here's the drive sprocket sub-assembly. Help me with some boundary conditions.
What we want to do is we just want to concentrate on the sprockets. So we want to use this great tool called the bolt connector, and that's going to tell us exactly whether the bolts will fail, which bolts will fail, and tell us how many bolts we need to get this thing to work.
Awesome. And to set that up, I have to suppress the bolts I already have.
Absolutely. Just take away everything you don't need. It's going to make it faster, and you get your answers quickly.
And now we're ready to just do a static study.
Yep. Apply your motor torque, a bit of dead load for the track, and then most importantly, just go through and create these bolt connectors between all our parts.
All right, let's take a look at the results now.
Well, because when we created those bolt connectors, we gave each bolt connector a strength, we can actually use something called the bolt check plot. If it's green, you're good to go. If it's red, you've got some problems.
It's green.
It's green across the board, so it looks like you can actually make this thing.
So, Mr. Voice of Reason, would you let your kid ride in this thing now?
Well, Max is 9 years old. I think he's going to want to drive this thing.
Cool. Well, I'll let him drive it.
Excellent.
Thanks, Stephen.
Good job.
Prototyping is always helpful to get a sense of scale. Now, we've printed smaller pieces before, but as you can see, the Dimension 3D printer can go large as well. I mean, look at this, is perfect. Now is the moment of truth. I want to see how this thing fits on the axle. I can use the lug nuts from the golf cart. Everything's rotating clean. Nothing's rubbing up against the brake drum. I like it. I mean, I haven't seen a baby stroller with one of those before. The track itself is going to be made up of shoe plates that fit in between the two sprockets, and they're going to have a center guide to make sure they stay put and stay aligned. And then there's going to be a couple of pins that fit these end links to the shoes so that we can pull our track all the way around. All right, now that we have a fully integrated drive system, we can move on to the chassis and baby seat next episode. In the meantime, here's your vote. On the comment section of the Let's Go Design website, the famous Stig asked me if I could make the tracks look a little less like a tank tread. And Jeff Shaw wanted fenders over these dangerous tracks, so we're gonna take their advice and we're gonna actually put a fender on both sides. You guys get the vote on the material we're gonna use. Do you want steel woven mesh, a translucent polycarbonate, or something simple like sheet metal? Over the next few episodes, we'll take into account this vote and your previous votes on driver position and steering controls. Now keep those comments coming and make sure to check out the SOLIDWORKS tips and demo section on the Let's Go Design website. We'll see you here next time.